Hi guys, today's notes are on 1.1 to 1.2. We're going to be talking about parent functions and transformations today. So let's begin with what is a parent function. So a parent function is the simplest function of a family of functions and the general shape of a family of graphs. Okay, so a parent function gives you the shape of everything that could happen to these graphs. For instance, if we have linear, which is y equals x, we know that's a line. And if I take my x values and plug them in just this one time to get my shapes, then x is -2, so y is -2, right? -1, 0, 1, 2. And if we plot these points, we get this straight line continuing forever. And let's talk about then domain and range. Oh, sorry, I should put this in the right place. So the family name is linear. Apologies. I realize why I had this underneath. The rule is, or I should not say rule, maybe equation. Let's change that, is y equals x. Okay. And here's my graph with the table of values. The domain is all real numbers. Now domain means all possible x values. Which means I can take any x and plug it in and get any y. And range is all possible y values. So my domain is all real numbers. And how we're going to write this with a symbol or represent all real numbers is 2 lines with an R. Okay, now I want to be really clear. This is not like a IR situation. I will absolutely take points off if you do that. It's not IR. It's an R with a double lined. Okay, so I'll do it again on the side here just so you can see it. Ready? 1 line, 2 line, and then connect the R to the first line. Okay. And then y value, since I can plug in any x, I'll get any y, will also be all real numbers. Absolute value graphs are different. So here's our family name. Already here is absolute value, and our equation for absolute value is y equals absolute value of x. Now absolute value of x means the distance to 0 or distance from 0. So -2 is 2 spaces away, and since we're talking about distance, there are no negative values. You don't tell someone to walk backwards -5, right? So all of these values will be positive, and the positive values will still be positive because distance is always positive. So our graph starts off, and I'm going to start at 0, 0. It's the easiest for me. 1, 1, 2, 2, -1, 1, -2, 2. And this is a V-shaped graph. Our domain is all real numbers because I can plug in positives, negatives, fractions, whole numbers, right? All of those numbers work. But range, oh sorry, not double, that's all real numbers. Our range is not all real numbers. Our range is only positive values, 0 or greater. So since we can include 0, I'm going to say y is greater than or equal to 0. Okay. Quick check on greater than and less than if you're struggling with which one is which. L for left hand and less than. Right hand is the other one. So greater than is this symbol. And we add the equal to because there is a 0 point, right? So it can equal to 0, but it has to be bigger than that. Transformations are any changes to the graph while still preserving the general shape of the parent function. So what this means is if I start with a parent function of absolute value, no matter what transformations I make, I'm going to whatever I do to it, I'm going to still have a V shape. The question is how wide or narrow and where it will be on the graph. So the three basic types of transformations there are translations, which are shifts. Okay, so you keep the overall shape size of the graph and you shift things up, down, right, left. There are reflections, where it flips over the x-axis or it reflects over the y-axis. So a V shape like this turns into a V shape like this, right? Sorry. Reflections are like V turns into this. Or you can go side to side reflections. Dilations, what you learned in geometry, are now going to be called stretches and shrinks. And we do have to specify if it's a vertical stretch or shrink or a horizontal stretch or shrink. Horizontal is side to side, vertical is up and down. So vertical is y's and horizontal is x's. Okay, so if you're vertically challenged, you are a little on the shorter side, which means your y height is smaller. Now these transformations, all of these, like I specified in here, can be either horizontal or vertical. Let's start with vertical though. Okay, so they can be vertical, which are y values, up and down, or horizontal, which are side to side. Okay. Horizontal is in the x direction, and vertical is in the y direction. So we're talking about x values when we're going horizontal and y values for vertical. Now let's see how this affects a table of values. So translations are when you are adding or subtracting. Oops, add or subtract. And what you're doing at this point is you are taking a shape and you're just adding numbers, move it up, subtracting to go down, right? So the rule is f of x. Now f of x just means a function where we plug in x. It can be any function. So this f of x could be linear, it could be absolute value, it could be other shapes later on, but it means that I'm going to take any function and I'm going to add k. And whenever we add k, we're adding to all the y values. Okay, so notice x is on the inside, and so we're not changing the x here, we're changing the whole thing. Remember that f of x equals to y. Okay, so it's literally saying take y's and add k to it. We're going to go up or down. So this absolute value, for example, this is your parent. It tells you the general shape, right? So our parent table is going to be distance from 0. And so I have my graph here. And here's my parent. Sorry, it's a little crooked. So this is f of x. And now, if I take each of these points and translate them by adding 2 to the whole function, that means I'm adding 2 to the y values. Okay. So that means I'm going to take y's and I'm going to add 2. Okay. So our x values are going to stay exactly the same here, because I'm not shifting side to side. I'm going to take this and shift by adding 2. So this is f of x plus 2. So all of these numbers for the y values are going to be plus 2, plus 2, plus 2, plus 2, plus 2. So I will have 4, 3, 2, 3, and 4. And absolute value of x plus 2. So if I plugged in, I could also prove to you that I'm right. So if I took -2 and I plugged it in, the distance would be 2, and then I'm going to add 2 to it, right? This is a translation 2 units up. On the test, I'd be looking for the word translation, 2 units and up. So you're telling me what kind of transformation, how much it's changing by, and the direction. Now let's talk about horizontal translations. This one is going to be f of x minus h. Now, what this means is we're going to change our x values. Do you see how this number is literally inside the parentheses with my x? Okay, so that means I'm going to add h to all input values. I could also subtract. Okay. Now, one thing we want to notice is that you see that our h is negative, and it says x minus h. So I'll prove this to you in just a second. But what this means is that h, which is how much we're going left or right, this is our h, is not what you see. So if I see x minus 1, do you see here that h is actually equal to positive 1? Right? Because we have x minus and h. So that negative is already there. And if I had x plus 1, it would be x minus negative 1. So what we're going to do here is we're going to fill in our parent. We have 2, 1, 0, 1, 2. And since we are changing our x values now, you see the number is inside next to the x. Okay. We are now going to be changing our x values. Now, I know it looks like we're going to take x and subtract 1 to it. Okay, but h is our shift. It's not negative h that I see. So I need to take the opposite sign of what I see. Okay, so this h is what we're changing by here. And so since we're adding 1 to all of our x values, let's see what happens. So negative 2 plus 1. Oh shoot, I'm so sorry. I didn't white this out. So hopefully on your worksheet it is now whited out. I apologize. Okay, there we go. So x values will add 1, which means instead of negative 2, I'll have to add 1, so it'll be negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Our y values do not change. Okay. And if we graph this now, you'll notice my y values are the same, but each of my numbers in the x's has increased by 1, which means I've taken my entire v shape and I've moved it over 1 to the right. Sort of like, let's see if I can sketch it here. This is where we start, right? And then now I have taken f of x minus 1. So absolute value and parentheses, though those are the same thing. It doesn't matter. They're both grouping symbols. So x minus 1 in absolute values is a translation 1 unit right. And this is something you're going to have to make a note of, that horizontal translations move opposite direction of the plus or minus you see in equation. Okay, so in the equation we see a negative, but it moves actually to the right, which changes our x values by positive 1. Okay, let's move forward. So now let's talk reflections and see how that affects our tables now. The rule for reflections is a negative, if we multiply by a negative. Now, if I multiply my x's by a negative, that means I'm going to take my x like this, and if this is my y-axis, I'm going to take this x and flip it. Sorry, do you see how like it flips over? Okay, the y-axis. And that's side to side because you're going over the y, which is really weird because we think of y's as up and down, right? But the y-axis acts as a mirror from side to side. A vertical reflection goes over the x-axis. So it flips like this, and then it goes, upside down. Sorry, my fingers don't fit well here, okay? So this one, because y's are f of x, we're going to take negative times f of x. And that's the same as y's. So notice it's going to look like this for absolute value on the outside for y's. And x's are on the inside because inside is always horizontal, right? So just keep in mind, like everything inside is side to side, everything outside is up and down. So I filled out the parent functions for you. Since we are on the outside, that's a y value. Okay, y values. So we're going to change our y's. And we're going to multiply by negative 1. So I will have negative 2, negative 1, 0, negative 1, and 2, negative 2. So you see what's happened is all of these points up here are now flipping and going upside down. I'll do a quick sketch. Now you guys, in pencil, this is going to look like a crisscross. So what I recommend is you making a darker for negative f of x. And this is f of x. Okay. Negative absolute value of x is what we would call a reflection. But you can't just say it's a reflection. It's a reflection over the x-axis. And you could think of it as like a vertical reflection if you wanted to. But you don't have to write the word vertical. Okay. On the inside, we are going to change the x's. Okay. So we're going to take these x values and multiply by negative 1. So it'll be 2, 1, 0, negative 1, negative 2, and the y values do not change. Okay, in this case, guys, because we're at the vertex, if I reflect over the y-axis like this, do you guys see how like it doesn't actually change our values? So like this negative 2, 2 is still the same, right? This is not always the case, but it just happens when you're reflecting the parent function. But you can still say that this is a reflection over the y-axis. Okay, so anytime, and it's a horizontal, anytime you see a negative in front of the x, inside the absolute value, it's y-axis side to side. Okay, we've got last two, vertical stretches and shrinks and horizontal stretches and shrinks. The rule for vertical stretch and shrink is that it affects the y's. And so we will see that it multiplies all of your y values, which is the same as f of x. So we're going to take all of our numbers and multiply. A stretch is a whole number and a shrink is a fraction, which is like dividing, right? This one says we're going to take 4 and multiply it to all of your y values because it's on the outside. Okay, so it's a multiply, invisible multiplication that we don't see. I'm going to take all my y values. I'm going to multiply by 4, and that'll be 8. 4, 0, 4, 8. My x's do not change. And this is a vertical stretch, sorry, by a factor of 2. Oh, sorry, 4. What am I thinking? Okay, so now let's do horizontal stretches and shrinks. And we will call this f of, let's do b. Okay. I know I called this A, but let's call this B just so that we specify that there's a difference. The number outside does not equal to the number inside, right? These are different. So horizontal strings and stretches are inside the parentheses because they're multiplying the x value by this. Okay, so you're multiplying x values now. So let's see what would happen, okay? So what this is really saying is that my y values do not change. Sorry, give me a second. So if my y values were 2, 1, 0, 1, 2, okay, what would my x need to be? So let's take a look and check, because it'd be great to say like I'm going to multiply all my x's by 4, right? That's what it looks like, but something weird is going to happen. And so just like something weird happened over here, where we had to do the opposite of what we saw. So let's take a look. In order for me to get the answer of 2, 4 times what will give me 2? And it's going to be 4 times negative 1/2. Okay, so let's do a quick check. 2 equals 4 times x, right? And so if I divide by 4, divide by 4, that means x equals to 2 over 4, which is 1/2. So that's this one. Let's use that as a positive. 1/2. Okay. If I stuck in a negative 1/2, would that also give me 2? Yes, because we're talking about the absolute value. Right? So then this negative would become positive. So negative 1/2. Okay. If I did the same thing and I solve for x again, but set it equal to 1, this will give me 1/4. 0 and negative 1/4 also works. Okay. And so this is really weird. How our x's actually change is that we are multiplying by 1/4 instead of multiplying by 4. And this is what you need to note. You multiply by the reciprocal of the b you see. Okay, so I see 4 as b equals 4, but I'm going to multiply by the reciprocal. So for absolute value of 4x is a horizontal. And here's the thing, it's a horizontal shrink. Okay, would you guys agree that when you are multiplying by a fraction, you're shrinking, right? Because it's a fraction. Of 1/4. Okay, so here I want you to take a moment and see if you can fill these in. I want you to actually pause your video here. Okay, I know this is one of the first videos we've been doing, so it's very easy to just keep going and copy down all the answers. It's not going to do you very much good. What I want you to go do is look all over our front and back of this worksheet. This number at +5 is at the end, so according to my rules here, which one gives you the +5 at the end? You see that's this one? And then you can look at your example, how do you write your translation or transformation? Okay, so then I would write translation 5 up. You don't have to write units, but if you can fit it, even better. Okay, I'll write it in, why not? Okay, so pause your video. I'm going to pause mine and you'll see it pop up in just a second. Okay, here's my answer key. Please note that the +5 inside the absolute value has switched to a -5, which makes it go left. Negative turns to a positive, so positive x values are to the right. The two questions, check all of these. Horizontal shrinks and stretches also take the reciprocal. The two questions I asked myself are, does the transformation affect the x, which is inside the parentheses, or absolute value, or the y values, which is outside the parentheses, or absolute values? And then the second question is if I'm adding or subtracting to the x or y values, right? That's a translation. If I'm multiplying or dividing and the number is in front of the variables, then it's a stretch, shrink, or reflection. We're going to practice a lot more in class, so please just make sure you have your complete notes. You can also write questions here on the side. Sorry, I took up the space with this. 2 questions.